All right, hello again. In the previous lesson, we introduced exponential functions. Now we are moving into logarithmic functions. We got a little tongue-tied there. A logarithm is the inverse of an exponential function. Okay, so we looked at exponential functions. Now we're going to look at the inverse of exponential functions. So here are some quick rules. You have what it looks like. The log b of x equals y, and that means b to the power of y equals x. And again, this is the inverse of the exponential. A logarithm answers what exponent gives this value. For y equals log b as a function of bx, the domain is 0 to infinity, and the range is negative infinity to positive infinity, and the vertical asymptote is x equals 0. Exponential and logarithmic functions are inverses, and again, these are the quick rules for this particular lesson. Okay, now let's deal with example number one. Example number one asks us to convert between forms. Okay, it says rewrite each statement in the other form. So we have log sub 2, 8 equals 3. And then b is 10 to the power of 2 equals 100. Log sub 5, parentheses, 1 over 25 equals negative 2. Then d is e to the power of 3 equals 20, and 85 to the 1,000th approximately. Okay, so, or approximately 20 in that number. Okay, so this is actually an approximation. Okay, all right, so let's deal with part A first. So we want to start with log sub 2 parentheses 8 equals 3. Okay, so what does this mean? Because if you've never seen it before, you have no idea what this means. This means 2 raised to what power gives me 8. Okay, so when you see log sub 2 or log sub any number, parentheses this number, it's asking you what power of 2 would give me 8. Okay, and so the answer is 3, right? So in exponential form, that would be 2 to the power of 3 equals 8. Okay, so again, this is the inverse of the exponential. So this is log, this is exponential. So if we did, now this isn't 2 times 3, right? This is 2 times 2 times 2, and that would give you 8. All right, now let's look at B. So now we need to convert 10 to the power of 2 equals 100. So this, as you can see, it's already written in exponential form. To write it in logarithmic form, we have to ask a question. That question is 10 raised to what power gives me 100? And so the answer is there. The answer is 2. So this would be log sub 10 parentheses 100 equals 2. Okay. Part C. So C says the log sub 5 parentheses 1 over 25 equals negative 2. Okay. Now, so this means that 5 raised to what power will give me 1 over 25? And the answer is negative 2. Okay. So 5 raised to the power of negative 2 is 1 over 25. And remember, this is the same as saying a to the power of negative n would give me 1 over a to the power of n. Okay, so that's where we get this rule for. That's an exponential or exponent rule right here. Then D, we need to convert e to the power of 3, which equals 20.085. So a logarithm with with the base e, that's called excuse me, that is a natural logarithm. Okay, so we write it as a natural logarithm. It would be written as ln 20.085 is approximately 3. Okay, is approximately 3. So in other words, e to the power of 3, approximately 20.085, is equal to, or logically equivalent to, that right there. Okay, let's continue. Example number 2. Example number 2 says evaluate without a calculator the following. Okay, so we have log sub 2 32. Let's deal with that one first, okay? So log sub 2 32. So this is asking us 2 raised to what power will give us 32, okay? For me, that is going to be 2 raised to the 5th power, okay? So 2 raised to the 5th power is essentially the answer to this question. So in reality, this is the exponential form. So the logarithm for this problem is log 232, which equals 5. Because if you did 2 times 2 times 2 times 2, 5, or 2 times 2 5 times, then the result would be 32. Okay, so this is the answer right here. Okay, now let's look at B. B, we have log of 3, 1 over 27. So that's log 327. And remember, when you see excuse me, that's 1 over 27. 1 over 27. So whenever you see this, whenever you see a fraction in here, you need to automatically know basically what the multiple is here. 3 times 3 would give you 9, times 3 one more would give you 27. So 3 raised to what power would give you 1 over 27? We know that 3 to the third power will be 27. So 3 to the negative third will be 1 over 27. Okay. So 3 to the third, and I should probably put a semicolon here. 3 to the third, 3 to the negative third would give me 1 over 27. So the final answer for this one would be log sub 3, 1 over 27. That's going to equal negative 3. Okay, so get part C. Let's see, that is log 10 to the 1000. Okay, so log 10, 1000. Okay, so again, using the same principle, 10 raised to what power will give us 1000. 10 raised to the third power would give us 1000. So this would be 3, because 10 times 10 times 10 be 1000. Okay, and then let's see, A, B, C, D. So this is a natural log. So this is ln e to the 4th. Now, so what this means is log base e. So this is essentially asking e raised to what power equals e to the 4th. Okay, e raised to what power equals e to the 4th? And the answer is 4. Okay. Now, pause and try the following problems at the bottom. Okay, so again, I'm going to start here. So what number multiplies to 4 would give me 64? The answer is 3. 4 times 4 is 16. 16 times 4 would give us 64. So log of 4, 64, that's going to equal 4, because 4 raised to the 4 power is 64. Okay. Log sub 1. Log sub 1, as a matter of fact. So when this happens, any any valid base raised to the 0 power is going to equal 1. So don't be alarmed like, oh man, what number raised to a power of 7 is going to give me 1, because you're thinking like, hey, 7 is larger than 1. But any number raised to the power of 0 will give you 1. So log sub 7 equaling 1 is very, very it's a common one. Anyone that's raised and you get 1, you're always going to end up with 0. Okay. So again, 7 raised to the power of 0 is going to be 1. Okay. And that's true for any number raised to the power of 0. Then we have a natural log. So a natural log, and again, this means the natural log of 1. So ln means log base e. Okay, ln means log base e. So this asks me that e raised to what power is going to give me 1. All right. So again, e raised to the power of 0 is going to give me 1. Now, the solution again is going to look like that. So notice the difference, but also the similarity in these two problems. This is a natural log. So anytime you see a natural log, it's going to be e raised to something. And so just like that's why the exponent ended up being the solution here. Okay. Then write log sub 6 216 equals 3 in exponential form. Okay. So we have so this is written in logarithm form. So this is essentially asking me 6 raised to what power will give me 216. Well, 6 times 6 times 6 is 216. So the answer is 6 raised to the third power. Because 6 times 6 is 36. 36 times 6 would give you 216. Okay. Very good. Let's continue. Example number 3. Example number 3 says, for f of x equals log sub 2 parentheses x, make a table using the following and 8, state the domain range and vertical asymptote. So we're going to evaluate each logarithm by asking 2 raised to what power gives this x value. Again, 2 raised to what power is going to give us this, and this, okay? So you probably are like, okay, well, that's super easy, and you're absolutely right. So we're going to start with 1/4. So log sub 2 equals 1/4, okay? Remember, this is, we know that this is going to end up being a ton of a to the negative. Anytime you see a fraction, it's going to be a to the negative n, and then it's going to give you a over n. So just familiarize yourself with the exponent rules with respect to this. This is going to be -2, right? So the first point is 1/4 -2, okay? Because the output, input, output, input, output. Then next we have 1/2. That's going to be log sub 2, 1/2 equals. So 2 raised to the power of -1 is going to give you 1/2, okay? 2 raised to the power of -1 is going to give you 1/2. Then we have 1/2 -1. Then we have 1, okay? So that's log sub 2. 2 raised to what power is going to give me 1? We looked at that. That's 2 to the power of 0. Oops, I didn't mean to write that there, but the 2 to the power of 0 is actually 1. Okay. 2 to the power of 0 is actually 1. Right. So that would be 1, 0. Okay. Okay. All right. So again, 2 raised to the power of 0 would be equal to 1. All right. Sorry for the confusion there. And then now we have 2. So that would be log sub 2 what number raised to the power of 2 is going to give us 2? That would be 1. Okay, would be 1. So that would be 2, 1 is that point. And then we have 4. So we have log of 2 equaling 4. 2 raised to what number would give us 4? 2 raised to the second power would give us 4. So that is 4, 2. And then finally, 8. So log 2 becoming 8. So 2 raised to what power would give me 8? That's 2 raised to the third power. That would give me 8. So that it would be 8, 3 as the point. Now, it says state the graph features. A logarithm function only accepts positive inputs, okay? As we mentioned earlier, the domain is 0 to infinity, okay? And that's at the very beginning. A logarithm function only accepts positive inputs, okay? Only positive inputs. Now, the outputs can be any real number, right? The outputs, which are the range can be negative infinity to positive infinity, okay? So the graph approaches the y-axis but doesn't touch it. So the vertical asymptote is x is equal to 0, okay? X is equal to 0. That is the vertical asymptote, right? Okay. All right. Example number 4. So we have a function, g of x equals log parentheses x minus 3 plus 1. Notice the shift. So state the transformation from the base. Remember, this is a parent function, and the vertical asymptote, domain range, and then 2 key points. Okay, so f of x equals this. This is a parent function. Okay, that's a parent function. And then we're going to compare that with this. Okay, so we have f of x equals log 2 and x. And then we have g of x equaling log sub 2 parentheses x minus 3 plus 1. But notice there's 2 types of shifts that happen in x. There's a shift right here, right? Negative means you go to the right. And then over here, it says plus 1. So this is a shift in the y-axis, okay? So x minus 3 inside the logarithm shifts the graph to the right 3 units. So that would be right 3, okay? That's what this means. And then the plus 1 means up 1, okay? So the parent graph has a vertical asymptote of x equals 0 because remember, the domain cannot be negative. After shifting to the right 3, the vertical asymptote becomes x equals 3, okay, because there's a shift. Now the input, x minus 3, must be positive, right? So if the input must be positive, that means it cannot be less than, excuse me, it must be greater than 0. So x minus 3 must be greater than 0. So we add 3 to both sides. X greater than 3. So the domain is simply 3, comma, positive infinity. The range is still all real numbers. The range doesn't change. Negative infinity, positive infinity. Now, it says find 2 key points. Okay, so all that is just substituting terms in there, substituting numbers in there. We can find 2 key points by shifting the parent points, right? The parent point is 1, 0. So we shift that to the right 3 units and up 1 unit. Okay. So if we do that, go to the right 3 from 1, that's going to give us 4. Then we're going to go up 1 from 0. That's going to be 4, 1. Okay. So the parent point 2, 1, the parent point 2, 1, shifts right 3 units and up 1 unit. So that would be 2, 1, tending to 5, 2. So these are the two key points in this problem here. Okay. All right, let's continue. A common mistake. A student tries to evaluate this problem here and explain why this is not defined in the real number system. So this expression here asks us to raise 2 to what power would generate -8, but powers of 2 are always positive, right? Because 2 raised to, let's just say, you know, any number is always going to be greater than 0, and that's for every real y. Okay, so for every real y, it's always going to be greater than 0. So this really doesn't make any sense. There are no real exponents that would make this -8. So log sub 2 -8 is not defined in the real number system. Okay, so log sub 2 -8 is not real. Okay. For real algorithms, or excuse me, for real logarithms, the input must be positive. Log input must be greater than 0. It just must be like that. Okay. All right. The final analysis. So we looked at logarithm functions. Log sub whatever number is a function of x, and that's going to equal y. And then the exponential form is essentially saying that b raised to the power of y is going to generate x. So b raised to a power of y is going to tell me what that x is. A logarithm answers what exponent gives this value. And then for y equals log sub base x, always understand that the domain is going to be positive and it tends to infinity, and the range is always going to be this, unless stated otherwise. And then the vertical asymptote is x equals 0. Exponential and logarithm functions are essentially inverse of one another. All right. That concludes this video. Again, thank you for watching.